Good morning. I am Salvatore Borrelli from CIRA. I am the head of propulsion division in CIRA. And my talk today will provide an overview on the propulsion system or propulsion solution for hypersonic flight. And so no words about launcher system, no words about re-entry system. Nevertheless, we in CIRA, we have in charge this kind of topics and activity also in re-entry and launching system. Just to introduce the problem, we know that if we want to fly higher than now, we should change the propulsion system. Nowadays, the flight, all the available airplane flight with the turbojet engine, but the maximum speed, I take for example the SR-71, fly to Mach 3 or around Mach 3. If we want to go faster, we have to change the propulsion system. And we have only 3 other solutions nowadays, ramjet, scramjet, or rockets. Advantage and disadvantage for these 3 systems is essentially to the complexity and the efficiency of the system and the need for rockets to bring with you the oxidizer, the oxygen, the air, while the ramjet and the scramjet can take the oxidizer from the atmosphere during the flight. And this is the reason why we want to fly by using this system, ramjet and scramjet. Even though we have not in our hand this kind of system, we are working all together, all the community, trying to develop this kind of engine. Advantage and disadvantage of this kind of system and the applicability. Applicability of the system is for civil transportation. We had a long study within Europe regarding the transportation system using scramjet engine. I will describe this just now. But of course, a weapon system, if we want to reduce the time to target, we have to increase the speed. And the only way to increase the speed is to use more efficient engine. And again, ramjet and scramjet. And of course, if we want to have a launcher with a higher efficiency, reusable launcher, where we can think to stage to orbit system, and the first stage of stage to orbit system will fly at Mach 8, Mach 7, and again we need a different propulsion system, ramjet or scramjet. Hypotheses to work with this kind of propulsion system are essentially 2. One is the strong integration between the airframe and the engine itself. For all the hypersonic system flying with scramjet, the bottom part of the vehicle is the engine, and the first part is the inlet, the central, the core is the combustion chamber, and the rear is the propulsion nozzle. But it's all the bottom part of the vehicle, and this is the reason why I marked that the airframe engine integration is one of the main hypotheses to develop this kind of system. The other one is the strong optimization of the injector system itself. If we want to burn fuel in supersonic flow, we need to design with very careful the injection system, otherwise the flame will be strap on. Advantages are mechanical simplicity. We don't need rotating machine because we can compress the air by means the inlet without any compressor, and this means that we need no turbine. We have very high propulsion efficiency, very high with respect the efficiency available with turbojet, because the inlet should reduce the speed from flight speed to the supersonic speed and not subsonic or very low subsonic speed that is the characteristic speed inside the combustion chamber of the turbojet. And of course, we have a very wide Mach number range from 2 to 8, there are 6 numbers with respect only 3 from 0 to Mach 3 with the standard turbojet. Drawback that we have very high thermal loads for combustor and nozzle, and we need to adapt the geometry of the engine, and again the geometry of the vehicle to the flying condition. CIRA is, of course, since many years working on this topic. The interests are the standard interests of CIRA, and so to create an Italian competency and collaborative approach to reach the goal I described just now. And of course, to represent the connection between the Italian interest and the European and international community working on this. And we developed a number of activities, moving from design of propulsion system itself, derive the aero database for hypersonic propelled vehicle. Again, I have to stress that hypersonic vehicles are very strong connected in hypersonic vehicle. The propulsion system and the shape of the vehicle are one thing. And then we are working for flight experiment. And already mentioned the ExaFly INT project, started from previous activity we developed for civil transportation, and then some ideas on the future, the possibility to apply this kind of system of tactical missile. Again, we already mentioned the ITEM project, the use of MHD technology. Lionel Marraffa just introduced, and I know that there will be another presentation from Bologna University on this technology. Well, it's possible to apply this technology also to propulsion system to reduce the heat loads and to stabilize the flame, and I will show you quickly one slide on this. And third and the last idea, how to have some testing capability. We are working to develop a rocket facility in CIRA, but very simply, it's possible to change the application of this kind of facility to also ramjet engine. Which kind of application we can think for hypersonic flight? We can think to long-range civil transportation within Europe, financed by framework program. Along the last 10 years, all Europe worked on different solutions. The one on top left is the first concept based on idea of Israel in a British company that worked on a civil transportation system based on ramjet engine. On top right, an evolution of the idea for a long-range civil transportation based on ISA-STEC concept. This is based on a scramjet engine, but also the ExaFly. This is a sort of evolution of the first two. Is the evolution of LAPCAT program in ExaFly, where all the world work together to have an experience of flight. And I want to answer a question that was done 5 minutes ago. Has Europe capability to develop a sort of this vehicle? The answer is, of course, technically, yes. Economically, I have some doubts, and this is the reason why we should put together around the table a number of continents, and not only Europe, in order to have a flight, an hypersonic flight. But we are working on this kind of application. And the last is the possibility to have a tactical missile and dual use of scramjet based on scramjet engine. I will move very quickly to show you the possibility of this engine. This is the English solution by REL. This is a very complex engine because should accelerate the vehicle from the railway, from the airport, and so we need an engine that is also to put the vehicle in the right condition to start a scramjet. Another drawback of a ramjet, a scramjet, that they cannot start from the airport, but they can start from supersonic flight, and so we need a system to accelerate the vehicle to supersonic flight. This is one of the possible solutions. It's a very complex engine where we put together three different concepts: a turbojet that is able to accelerate the vehicle from the start, and scramjet and rocket in order to have ramjet and rocket, ramjet and rocket in order to assure the cruise, the ramjet vehicle, and the rocket in order to have more power if need. A lot of work was done within Europe for this kind of concept. You can understand the complexity of the burner, the combustor chamber, that should stabilize the flame, even if for ramjet engine, the flame work at Mach 0.7, Mach 0.5 is a critical condition, but not supersonic one. Even this, we should deeply work to refine the concept of the engine in order to assure the flame stabilization. I will skip this, even if it's very good shape, in order to understand if the provisional means, the CFD codes, are able to match experiments. And you can see that the technology we have at this moment can assure this. Quickly moving to the scramjet engine, this is the evolution of the previous vehicle. This is a fully based on scramjet engine, and again, for this kind of engine, we should assure the positive balance between the drag of the vehicle and the thrust provided by the engine. And you can see that if you work deeply, you can assure the utilizability, the availability of this kind of propulsion system, and the possibility to trim with a positive net balance thrust to drag condition. Again, you can see that the engine itself is very critical engine. You need to stabilize the flame, and in this case, I want to point out that also the simulation means should be very, let me see, well tuned, because the simplification, simply geometrical simplification from 3D to D, does not provide a good solution. The 2D solution is very different to 3D, just in order to stress the need to very careful calculation in order to understand the capability of this kind of engine. I will move, these are example of the same engine and some wind tunnel test for this kind of engine done in Germany at DLR. I want to move to the flight experiment. That is for now for us is a wish. We are working to have this kind of mission. We will use a rocket in order to put the vehicle, the experimental vehicle, in the testing condition, because we have to accelerate at supersonic Mach number. And the way to accelerate to a supersonic Mach number is by means of a rocket, or a sounding rocket, that will deploy the vehicle at a certain altitude and certain flight condition. At that point, we can start our investigation, aerodynamic and, for me, propulsion, during the maneuver, the re-entry maneuver, but this is not a re-entry from space, but simply energetic re-entry in order to reach the needed flight condition. Again, an example of the layout of the vehicle. You can see that the experimental vehicle, that is only 4 meters long experimental vehicle, is a payload for the sounding rocket, and able to inject the vehicle in the flight. I will skip this slide again. Just one word about tactical missile. Again, if we want to reduce the time to target, we need to fly at very high Mach number. If you want to fly at a very high Mach number with the reduced weight of the engine, we need a different propulsion system. And the only propulsive system is ramjet or scramjet. And this study show you that this solution can be applied to tactical missile. Just one word about the MHD as promised. We can apply this kind of technology to reduce the speed at the inlet and to accelerate before the nozzle. If you apply this kind of technology, you can take the energy from the nozzle and put the energy in the inlet. And so take the energy to decelerate the flow at the intake. And so without any other injection of energy, that is the standard problem for reducing the speed and to accelerate again. Applying the magnetic field, by applying magnetic field, you can do this thing. And this chart show you the balance of force that again show you that this kind of solution can provide advantage with respect scramjet engine without MHD technology. One chart about the possibility to have a small test facility. We are designing, we are fabricating a small facility at CIRA to test rocket engine, but simply moving some compressed air in the same area, and we have compressed air in this area, and adding some heating the air, we can use the same cell for ramjet engine, and it's possible to test interesting ramjet engine with different combustion system, methane or GP4, with a sufficiently long thrust chamber, 20-30 centimeter, and up to 1 meter and a half for the entire chamber. For ramjet, these are good numbers. For scramjet, not sufficiently. Conclusions. CIRA is working since 10 years on this kind of solution, and we move towards a number of topics, even if we have no experimental capability. But working together with all our friends in Europe, we were able to develop a physical modeling of problematic combustion, verify the capability of design system like CFD, support new testing, support the project of vehicle, support wind tunnel experiment, and the technology we have actually in our hand can bring us in the position to contribute for the future mission, contribute for studies for dual-use application, and understand the future of this kind of propulsion system.